Hi, all of you. Good afternoon. Sorry. Hi, Venkatesh, Dhruv, Priyanka, Jyoti, Darshan, Tanish. Yeah, happy Diwali, happy Diwali. हाँ, ठीक. Thank you, thank you. Thank you. I'm good, very nice. Hi, Aditi Arya. Good afternoon. Yeah, happy Diwali after we have done Wagner's theory. Okay, we'll keep some celebration for that. Chalo, let's start off, round up now. I see a marked change in our study times, in my college life, and what I see now. You, my children, uh, some people I know, their kids. Back in my times, at least uh, what I can remember, whenever we had holidays, we were more happy not going home. Okay, stay back, make some excuse. As anything, we enjoyed studying, but staying back in the hostel, staying back, with the friends, Holi, Diwali, Christmas, whatever it was. Any excuse we found, like we would stay back and we would plan out sometimes, go out together. But lately I see most of you are very happy going back home. I don't know if we as parents are very good parents and not our parents are nice. Okay. Or maybe, the communication is faster, whatever the reason. Even going to school, I used to, not just me, I can tell you at least about the friends I had and all of us. We used to hate holidays. घर जाके, homework ही करना होता था. It was nice to stay at school, play there. पढ़ाई हो जाती है. Okay, it happens sometimes. But I never thought, going back home is such a big deal. But मैं देख रहा हूँ in the last 10-15 years and more, people are always homebound. कोई मौका मिले घर जाएंगे, वीकेंड्स हैं घर जाएंगे. I don't know what's amiss here. Maybe, I would like to write about this. In fact, maybe the social media that we have actually does not give us good connections. Maybe the sense of good camaraderie, the sense of good friends, maybe it's missing here. Even if you are among your classmates, even if you're amongst your friends, maybe the belongingness is different, if not good or bad types. Yeah, Abhirup, I don't know what was your experience there. Okay, I can see that, and this is part of some social dynamics. It's part of, nahi, ghar ka khana, believe me, Aditya, back in my days also, ghar ka khana was nice. पर घर के खाने के साथ में जो पैकेट्स था घर, okay, we said नहीं यार हम बाहर खा लेंगे, कोई दिक्कत नहीं. Okay, we're happy with the bread, butter, okay, omelette, Maggie was always, okay, back, 1980s, 1990s onwards, entire generation has lived on Maggie as a staple food. अभी भी अब हिल्स में जाओगे ना, okay, mountains, the staple food is no longer rice, okay, or wheat, it's Maggie. Maggie masala, Maggie bland, Maggie Fanta here, God knows what is that. Okay? So anyways, it's a nice case study for me. Figure out what's changing. Okay. क्यों इतना घर भागते हो आप लोग? Okay. If enjoyment is what you need and fun you what you need, I think fun is outside home. Okay? Chalo, anyways, that's your choice. बाहर का खाना is too bad. No, no, Shivam. बहुत options हैं आपके पास में. You do not know what's bad food. Okay, so I will not buy that argument. Swiggy, Zomato, घर वाली दाल, okay, paneer, your choice. इतना options कहाँ होता था? The first time I ate pizza was when? I think Bombay में खाया था मैंने. I left home, went to work in Mumbai, late 90s में. KFC had just opened. Okay, वो एक चिकन खाने के लिए अपना बर्बाद करो 2 घंटे का वेट लाइन में. अच्छा, anyways, so whatever. So we have started off with the continental drift theory. Okay, and I said this theory is about the Earth's surface. How does it change? How the features are formed, mountains, rift valleys. Why do we have volcanoes? Why do we have earthquakes? Essentially, we were looking at, or we wanted some kind of a comprehensive theory to explain the dynamics of the Earth's surface and the features associated. तो एक हमें थ्योरी चाहिए था. One theory which could tell us everything about what's happening on the Earth's surface. Continents कैसे बने, oceans कैसे बने, why are the rocks different, why mountains in some places, why rift valleys somewhere, why earthquakes somewhere. So that's the objective. We wanted one comprehensive theory. One version of the theory was, I said, the concept of permanency of oceans and continents. There was an American by the name of Harold Jeffrey. Harold Jeffrey, he had given this concept, the concept of permanency of oceans and continents. And he said that when Earth was forming, right in the initial origin, जब Earth बन रहा था, at that time the continents and oceans were formed, and once formed, the oceans, continents have remained like that. फिर कुछ change नहीं हुआ. Okay, the mountains have existed since then. The oceans have been since then. Whatever landforms we have, the origin largely you can trace to the origin of the Earth. But this meant that all mountains have same age, all oceans have the same age, all continents at the form at same time will have same features. This was slowly getting challenged. And one of the first challenge was Taylor. F.B. Taylor, 1908. And he said that continents do move. There was a large continent called as Pangea that broke up. The pieces move apart, they again collide back. Earth is impacted by sun and the moon. Some ideas there. Now, the ideas of Taylor were taken by Wegener. Okay, and Wegener gave us a more detailed theory with postulates, evidences, driven mechanism. Okay. So one of you asked me, just walking in the class here, कि अगर MCQ पूछा, who is the person who gave us drift theory, and choice में Taylor भी है और Wegener भी है, हम क्या मार्क करेंगे? Number one, what does an examiner think and what he wants out of you is not always same as the concepts that you have read. Okay. Fact is, the beginnings of the theory was Taylor. The more popular theory was Wegener. तो आप either को मार्क करो, सही होना चाहिए. अगर ऐसा क्वेश्चन पूछा, आपकी किस्मत, राइट? इट्स अ डेस्टिनी देन. एग्जामिनर क्या सुनना चाह रहा है, यू हैव नो क्लू. ओके, एंड ऐसा क्वेश्चंस जनरली होते नहीं है, राइट? सो वी मेक अ फैलेसी ऑफ क्रिएटिंग आवर ओन क्वेश्चंस. ऐसे पूछे तो क्या होगा, ऐसे नहीं. पूछा है क्या, कहीं देखा है क्या? You know your facts. Because when we make questions ourselves, we can make questions only from what we know. ठीक है? तो ये एक fallacy होता है. So don't bother about that. You must know that both names are important. Taylor started the process. Lot of concepts was given by Taylor, but Wegener gave it a proper shape. अब who can I give credit to? Who was the creator? This is a debate. जैसे geography में we say the father of geography is Humboldt and Ritter, for example. Some of you heard. Okay. But some other scholar can say no. We think father was Varenius maybe. Some Greeks say the father was Eratosthenes maybe. Right? If it comes to India, God knows, we can have our own names. Bhugol किसने बनाया? Okay, I can have my own idea of who the father of geography should be. तो ऐसे क्वेश्चन डिबेट नहीं होता है. I mean, somebody says, you just remember it. ठीक है? So, the initiation of the theory was Taylor, but the more popular one, the more talked about is Wegener. Just start off from there. Yes, Aditi, that is in your NCERT. Okay, Abraham Ortelium observed the matching coastlines mentioned है आपके NCERT में. In the book मत बोलो, मैंने पढ़ा NCERT. Okay, so good, nice that you have read it. There are many more people. There's a man called as Francis Bacon. He was a British novelist, a playwright. Also, he has traveled a lot. When he said the coastlines are matching. So just some names tell us that the matching coastline was observed, but then okay, it was Wegener who tried explaining it as a part of a proper process. Okay? So I've initiated what Wegener is. Now, Wegener का postulate क्या है? Let me clarify this thing to you. Maybe some of you know this. Wegener was not a geologist. Wegener was not even a geomorphologist. Okay, he was a mythologist. He was a person studying climate, and he wanted to construct the history of Earth's climate. He was a climatologist. To know what was the climate 1000 years ago, what was Earth's climate 1 million years ago, what was Earth's climate 200 million years ago. He was reconstructing the Earth's climate. In reconstructing the climate, he was looking for evidences of the climates. The evidences कहाँ मिलेगा आपको? आपको मिलेगा rock से मिलेगा. If a rock has lot of coal, that means that area must have had forests. If one area has lot of swamp fossils, that area must have been wet and humid and swampy. If the area has lot of coarse-grained textured rocks, the area must have been dry. Dry conditions में the sediments are coarse, large grains होते हैं. So that is how he ends up studying rocks and fossils. Okay, so whatever Wegener says is not Wegener's ideas actually. Okay, Wegener is not a geomorphologist. उनको पता नहीं है Pangea था नहीं था. So he has taken some ideas from Taylor. He has taken some ideas from other geomorphologists. He has taken some ideas from paleontologists. Some studies from archaeologists. So Wegener का brilliance है, he is putting all of it together. So none of his ideas are actually his. It's like, I made a beautiful house. Fact is, मैं थोड़ी बनाया है. My brilliance is, I could get the best carpenter, I got the best mason, I got the best architect, I got the best home designer, and they have made the house. But my brilliance was, I got them together. So none of Wegener's ideas are actually his ideas. But he could see a connecting thread in the concepts. अच्छा, यहाँ पर ये ऐसे बोल रहे हैं, यहाँ पर ये ऐसे बोल रहे हैं. And I can see और इसके link एक है. Okay. The brilliance of Wegener is, scientifically relating and mapping lot of concepts that were disparate, that were not seen as part of one common idea. Okay, so the idea of Sial Sima, ये भी इनका idea नहीं था, right? Sial Sima idea was the idea of Edward Suez, and he says, I agree with that. Continents are Sial and oceans are Sima. The continents are floating over Sima. इनके पहले somebody had already said there was a supercontinent called as Pangaea. ये Taylor कह रहे हैं already. Somebody already said the Pangaea broke up into northern Laurasia, southern Gondwana land, and they moved apart. This also Taylor had said. Okay. Then he said that this movement, as the continents are moving, they are scraping the ocean floors, and that's how they create mountains. ये idea भी Taylor ने कहा था. When Sial is moving, it will scrape. It will start removing sediments. The sediments will pile up. Remember I told about Taylor? North में you have Angara land, Laurasia, south में Gondwana है. They collide together और बीच में क्या बन गया आपका? The Eurasian mountain range. Because the continent is scraping and squeezing the sediments between them. So Taylor is taking ideas from all other scholars and is weaving them together. He is putting them together as a part of one single coherent theory. And like I said, he just did not give us the postulates. He also gave us evidences in support of his postulates. क्या अच्छा ये मैं कह रहा हूं, इसका evidence भी है. So that's how Wegener's theory becomes a bit more complete. Okay, and the evidences of Wegener's drift idea is, one is the shape fit, that the coastlines of the continents, they seem to match. और कल मैं diagram दिखा दिया आपको, remember? So we have Africa. That's Africa, and that's South America. That's South America. Something of this kind. South America fits into Africa. Okay. So this was the idea of the jigsaw fit. And ऐसे कुछ fit was also happening for North America also. So North America was probably something like this. Okay. तो ये part Florida है, parts of Atlantic coast, these parts of North America matching with some of the rocks here. So he is telling us that the shape is a good indicator. But then shape को और refine करने के लिए said not just the shapes are matching, because shape match can be a type of a coincidence. Even the rocks are matching. The rocks I have in parts of Brazil, यहाँ Brazil country है, similar to rocks we find here. The rocks we find here are similar to rocks found here. The rocks that we have, okay, in parts of US also same as the rocks in parts of Africa. There's some similarity there, and this similarity, he says, is also found further northwards in parts of Western Europe also. Just to help you recall, this was the diagram, correct? So we have in North America, this part is joined here. Okay, so it's not the same shape we see here today, but here Florida region hai, and some similarities here. You can see Florida part here, some similarities here, and this is also similar as it goes northwards. And this similarity was found in the coal fields. So this is one mountain range called as Appalachian, likha hai yahan par, Appalachian coal fields. These Appalachian coal fields are similar to the coals we found in parts of Canadian islands, in parts of Belgium, Netherlands, in parts of Britain. So this area, the coals seem to have been part of one single rock formation. We call this as the structural fit. And I gave some more examples about how even Indian rocks, so somewhere here, India back in before about 90 million years. Okay, India was somewhere here, around 100 million years. सोच लो आप, India was somewhere here. So the rocks we have in Madagascar are similar to rocks we find in parts of Karnataka here, and not just rocks, even the life forms. There is one special type of a pine tree, जो सिर्फ कर्नाटक में मिलता है. I forget the name of that. And that pine tree has its corresponding type of trees in Madagascar. जैसे Western Ghats में they find a frog called as purple frog. The purple frog is similar to some of those frogs found in Madagascar. So not just the rocks, you have similarities of vegetation, similarities of life forms also, because they are once a part of one common landmass. Okay, so abhi hum baat kar rahe hain about rocks. We talk about this as the structural match. Okay, so 3-4 examples, and in geography, I repeat, you need to draw these diagrams. All the students, while you are making some summaries of your class notes, I hope you all are doing it. You also start making small summaries of diagrams. So all geomorphology diagrams, maybe in 2 or 3 sheets. Small. एक sheet में आराम से 10-12 diagram आ जाएगा. Look at this A4 page size ऐसे. You can divide like this. Okay. So you can have 12 odd diagrams in this. Okay. So make it a habit. Without the diagrams, you will not score enough marks there. Okay. So what is the structural fit and what is the shape fit in the evidence of Wegener's drift theory? I revised what I discussed yesterday. Any doubts on this? Any questions on this? Anybody? Online, offline? Rajender, Aditi, Venkatesh, Dhruv. Any doubts? All good? All fine? So Wegener was using the observations of Snyder, Priyanka. Okay. He is using the observations of other scholars and is putting them together into one single set of evidences. All fine, all of you done? Yes. Lemur is one type of animal. They are like rodents bolo. They are one form of rats bologe or whatever. Okay. So they are one type of animals, lemurs. They are typically found in parts of Madagascar. Okay. Anybody else here? Sorry. Chalo, let's move on then. The third evidence, I've done 2 of them now. The third evidence is fossil evidence. The third evidence is fossil evidence. Like what I said, that not only do we have similarities of rocks and shape, we also have similarities of certain type of life forms, their origin and their distribution. So again, see, when life was originating on the planet, life did not originate everywhere at the same time. Even human beings, if you know Homo sapiens sapiens, our origin was from Africa. And slowly, gradually, okay, our population spread. So if you look at the history of plants, animals also, वैसे ही रहा है. They don't have everywhere. They say, I have a continent here. I have a continent here. I have a continent here. Australia, a life form called A, यहाँ हुआ originate. Okay. And I also find fossils of A here. I also find fossils of A here. I also find fossils of A here. It's very unlikely the same life form can originate at 4 places at the same time. Okay. Generally we say beginning से एक जगह हुआ होगा and then they would have spread. Okay. So when this idea was seen for a lot of life forms, the people couldn't explain it. There were other scholars who were studying life forms. How did the same life form evolve in 4 places at the same time? Okay. So some said that maybe the life form was formed here, evolved here. It swam across the waters. Okay, life form was evolving here. Maybe ancient, there was a land bridge. जो अब डूब गया शायद. Think of Adam's bridge that we have connecting India and Sri Lanka. Maybe ऐसा कुछ land bridge होगा. The life form could have moved across. But what if it's a plant? How can a plant float across? What if the life form is a land animal? How can a land animal swim across the waters? So this was a mystery for a long time. How can the same life form, fossils, be found at different places across continents? So the study was for many fossils. The main fossils were one type of a plant fern called as Glossopteris. A type of plant है, plant like, not exact plant, something like a plant. It's called as ferns. All of them are Mesozoic fossils. One type of a reptile called as a Mesosaurus. A Mesosaurus is a shallow water reptile. Then we have a reptile called as a Cyanonathus. It is again a land reptile. And they found the patterns for this. I'll show the diagram to you. That you know what we're talking about. Oh, where is it? Here. So this is a Cyanonathus, one life form. Fossils are found in South America and parts of Africa. The Cyanonathus is a land reptile. Cyanonathus, approximately some dimensions. This is Mesosaurus. Mesosaurus is a freshwater reptile. It can't swim in salt waters. It can't swim in seawater. It's a freshwater Mesosaurus. वैसे ये Glossopteris है, type of a fern, found in South America, Africa, India, Antarctica and also Australia. And remember today, the continents are very, very far apart. वैसे एक और fossil है called as Lystrosaurus. ये भी एक land reptile है. So all these are life forms of the Mesozoic times. So write something down. All write down. Before Wegener, it was noted that certain fossils of similar type and age, certain fossils of similar type and age were found across continents, separated by oceans. Found across continents, separated by oceans. The studies included number one, Glossopteris. Number one is Glossopteris, Glossopteris, Glossopteris. Within bracket write down ferns, the one type of plants, Glossopteris. Put hyphen. Found across South America, Africa, India. Found across South America, Africa, India, Antarctic and Australia. Number two, Cyanonathus, C-Y-N-O, Cyanonathus, C-Y-N-O-G-N-A-T-H-U-S, Cyanonathus. A Triassic reptile, a Triassic land reptile. A Triassic is a division of the Mesozoic times. Okay. Triassic land reptile hyphen fossils found across South America and Africa. Fossils found across South America and Africa. Number 3, Mesosaurus. 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 Hyphen freshwater Mesozoic reptile. Freshwater Mesozoic reptile found across southern South America and southern Africa. Southern South America and southern Africa. And Lystrosaurus, Lystro. And Lystrosaurus, again a Triassic land reptile. Found across Africa, India and Antarctic. Found across Africa, India and Antarctic. So you have to have some sense of a diagram. So draw along with me. This is South America, that's Africa, this is the old Indian bloc, Australia. So Cyanonathus found here, Glossopteris like this. Mesosaurus is here. And Lystrosaurus. So this is a Cyanonathus. This is Mesosaurus. This is Lystrosaurus. And this is Glossopteris. Draw the sketch, please, all of you. Your diagrams need not be artistic, but keep them neat with some semblance of the place that you are showing. These are all Mesozoic fossils. The distribution of Mesozoic fossils used as evidences by Wegener. रोहित, I do not know आप कौन सा follow कर रहे हो. It's always like this. North America fits here. The part of Florida comes here. All done, all of you? Okay. So what Wegener did was, he said, if you look at the fossils, okay, this is South America, this is Africa, this is India, this is Australia, and this is Antarctica. They talk about glossopteris. यहाँ मिलता है, यहाँ मिल रहा है, यहाँ पर है, यहाँ पर है, और यहाँ पर है. It's so scattered. So Wegener said it's simple. They are scattered today. In reality, they all must have been together once. Bring all the landform together once. Okay. When you bring them together, okay, this common stretch is where the evolution happened. And today, the landforms are broken and they moved apart. Okay. ठीक है, अभी दिख रहा है Cyanonathus is here and it's here. In reality, they were once together. You bring them together, Cyanonathus evolution was in this part. And today they have moved apart. Okay, so you're just using a bit of logic, how they must have come together. Okay, and they had common evolution. And then the landforms have now drift apart. Write down. Wegener explained the distribution. Wegener explained the distribution as a consequence of a common large supercontinent. A common large supercontinent breaking apart, and with it a common large supercontinent breaking apart, and with it the locations of fossil sites, and with it the location of fossil sites have dispersed across oceans. The locations of fossil sites have now dispersed across oceans and found in different continents today. And found in different continents today. Okay? This was the fossil evidence that why do we have this pattern of life form distribution when the life forms do not evolve in so many places at the same time. The fourth evidence is, give heading, paleoclimatic evidences. Paleoclimatic evidences. ये बहुत important है. This evidence is almost like a confirmed one. इसमें आपको debate ज़्यादा कुछ है नहीं. Okay, the paleoclimatic evidences, because he has told this to you already that Wegener was a meteorologist. He was a climatologist. वो climate ही पढ़ रहे थे. So this evidence is his domain. ये उनका इलाका है. It is his expertise. So he can't have made a mistake here. Baki is putting from other scholars. Okay. So first listen. So today's continents, if you see, that's equator, that's South America, that's Africa, we have India. Okay, this is the Tropic of Cancer, that's Australia. Okay, we have the Tropic of Capricorn, and that's Antarctica. And further north, this is North America, this is Europe. Okay, that's a representation diagram. ये tropical areas हैं. Tropical areas means what? They are relatively warmer. 23.5 degrees south, 23.5 degrees north. Okay, this is Antarctica. Antarctica is far, far cooler. If you look at, okay, the patterns of forests today, which area has the bulk of the forest? कहाँ पर है ज़्यादा forests? Dense forests. Tropical areas, we have got Amazon forests here, we have got Congo forests here, the dense forests of Andaman, Nicobar, Western Ghats, dense forests of Indonesia, Borneo Islands, Malaysia. Okay, so the densest forests we have are in the tropical areas. Equatorial है, savanna forest भी है यहाँ पर, ठीक है? So if you look at the vegetation, good amount of vegetation are in the tropical lands. Do you know how coal is formed? Coal is formed from what? From trees. They are fossils of trees, fossils of forests. So अगर tropical areas में forest है, tropical areas have lot of trees, so should we not anticipate the tropical areas must have lot of coal fields also? Right? Make sense? Okay. But if you look at the coal field patterns of the world, you realize Brazil में almost coal है ही नहीं. Very less amount. Africa, the biggest problem is Africa does not have good amount of coal fields. थोड़ा बहुत है Durban, South Africa में, but nothing really large. Some people ask, why is Africa so backward? One reason is, in Africa, the industrial revolution did not happen. Because Africa में two important minerals, which are the basis of Africa's, of any country's development are energy and iron ore. और ये दोनों चीज अफ्रीका में बहुत कम है. Africa has diamond, it has gold, it has uranium, it has cobalt, it has lot of rare metals, but coal, iron ore, the fundamental minerals of industrial development, Africa में बहुत कम है. India has lot of coal, but not good grade coal. I hope you know this. India has almost more than 350 million tons, okay, a billion tons of coal. But this coal is not good quality coal. अगर वर्ल्ड में आप coal fields देखोगे, the good coal fields are in parts of North America. North America has good coal fields. Okay, Canada has good coal fields. Good coal fields of UK, of Germany, of Russia. Good coal fields we have in parts of France. Okay, and these are the northern temperate regions. यहाँ पर coal मिलना नहीं चाहिए और इतना नहीं मिलना चाहिए. It's more than the temperate areas. This is one of the climatic anomalies बोलते हैं कि जहां पर forest है, where we have forests, where we have trees, and where we anticipate the coal to be formed, it has less coal. And where the trees and forests are not as dense, not as much, those areas have the bulk of the world's coal fields. We also have good coal fields in Australia. Okay, explain why. So this is one anomaly. The second anomaly is good parts of the subtropical areas and tropical areas, parts of South America यहाँ पर, parts of Africa somewhere here, parts of even India somewhere here, parts of even of course Antarctica तो है ही, some parts of Indonesian region. This region has lot of glacial deposits. We call these as tilites. ये एक और अनोमली है भाई, जहां पर कोल होना चाहिए वहां कोल है नहीं और ज्यादा कोल नहीं है. एंड ट्रॉपिकल एरियाज शुड नॉट हैव सो मेनी ग्लेशियर्स. वन प्लेस इन ओडिशा कॉल्ड एज तालचेर. तालचेर इज वेस्टर्न ओडिशा पार्ट है. वेरी हॉट रीजन्स, पार्ट्स ऑफ महानदी बेसिन. दोज एरियाज हैव ग्लेशियल एविडेंसेस. दिस पार्ट ऑफ तालचेर हियर. सो the coal fields are in the northern temperate regions and the glaciers are in the southern and northern tropical areas. This was another climatic anomaly. You can't explain this. So what Wegener said is आसान है. Essentially, all the land was once together, part of one continent. And this large continent was a bit more southwards. So that जो आज temperate regions में है, they were in parts of tropical areas. And तुझे जो tropical areas में है यहाँ पर, they were once near the southern poles. India was somewhere here, near the southern pole. Then it starts moving northwards. So this anomaly, as a consequence of continents breaking and moving, explains why we have the climatic variation, evidences that don't match with the present day climate regions of the world. Okay, all of you? So, iska, show this to all of you. Look at this diagram. Okay, so this is the equator. Look where India is. Look where South America, and this is 50 degrees, 75 degrees. ये polar subpolar latitudes हैं. Okay, North America देखो 25 degrees. यहाँ पर Appalachians हैं. Okay, Eurasian regions 25-30 degrees. This parts here, Germany. So if you look at the pattern, and Australia is near, this is the tropics today. Australia has not moved north-south. Australia moved eastwards. Australia was always around tropical subtropical areas and it moved eastwards. So the countries which are today in tropics, they were more in near the southern poles. The countries which are today in the northern temperate, they were in the tropical areas. So these areas form some coal fields and these areas have some amount of glaciers. Okay? Now Africa, okay, Africa is here, this part here. Africa, so यहाँ पर you not have enough of coal fields. We do have, I'm not saying zero नहीं है. Parts of South Africa में Johannesburg है, वहाँ पर coal fields है. We do have some coal fields in parts of Northern Africa, but ये वाला पूरा deserts है. It's all deserts here. We do have some amount of oil, gas in parts of Sudan, parts of Chad, but not as much as it should have been, given that Africa is almost entirely within the tropics today. Okay? Write down now. Back to your notes. Write down. There are two climatic anomalies observed which were not explained convincingly before Wegener. There are two climatic anomalies observed which were not explained convincingly before Wegener. Number one, the tropical areas of South America, Africa, South Asia, South America, of Africa, of South Asia, despite their tropical locations and dense forests, do not have the richest coal resources of the world. They do not have the richest coal resources of the world. इसी में next point, the northern temperate regions of North America, Canada, Britain, Germany, France, and Russia. Britain, Germany, France, and Russia have the more richer coal resources. Have the more richer coal resources. Okay? So that's one anomaly. The tropical areas with their dense forests, with their wet type of climate, they should have had coal fields, they don't have. The second anomaly is tropical locations, tropical and subtropical locations, tropical and subtropical locations of Patagonia, P-A-T-A, Patagonia, G-O-N-I-A. Patagonia is part of Argentina. It's a part of a plateau region, deserts वो भी हैं. Okay, they are part of Argentina. So, tropical, subtropical regions of Patagonia, comma, South America around Durban, South Africa around Durban, comma, South Asia in parts of India, South Asia in parts of India have evidences of glaciation and glacial tillites. Evidences of glaciation and glacial tillites, T-I-L-L-I-T-S, tillites. Tillites क्या होते हैं? They are glacial deposits. Okay, just within bracket mention, tillites are glacial deposits. Okay. And mention here, these locations currently are warm and hot regions. They are warm and hot regions and not locations for glaciation. They are hot and warm regions. They are not locations for glaciation. Next paragraph. Wegener explained the anomaly. Wegener explained the anomalies by proposing the ancient supercontinent Pangaea. The ancient supercontinent Pangaea was once located majorly in the southern hemisphere. Was once located majorly in the southern hemisphere. With the present day northern temperate locations, with the present day northern temperate locations in the then tropical areas with forests and therefore coal fields. The present day northern temperate locations in the tropical areas with the then forests and coal fields, while the present day tropical locations must have been further south, southwards towards subpolar and polar latitudes. The subpolar and polar latitudes. with their glaciation evidences. With their glaciation evidences. तो आपको जो समझाया मैंने बस लिखा दिया, that's something else. This was the Earth. Okay. Present day North America, present day South America, present day Africa, present day Europe. Okay. They were all once together. All once together. Okay. So North America, South America, Africa, Eurasia, Australia, Antarctica is up together. Together, the whole thing is a bit more southwards. So this is where we have North America, Eurasia, South America, we have Africa, and so on. So what is in the tropical areas today must have been in subpolar areas earlier. What is in the northern part today must have been in the tropical areas earlier. That's all. You put all the continents together and move them a bit southwards. The present day northern temperate latitudes now come in the tropical areas, and the present day tropical southern tropical areas, they come more in the subpolar latitudes. That's how these locations, when they have shifted down like this, so these areas can have glaciers and these areas can have the coalfields. Add one point here that paleoclimatic evidences are considered fairly confirmatory. They're considered fairly confirmatory of continental drift process. The fairly confirmatory of the continental drift process. Otherwise, ये anomaly आप किसी और तरह से समझा नहीं सकते आप. So this is almost like a confirmation. Yes, continents have moved. Okay. Otherwise, you can't explain why these type of anomalies happen with their difference in the coalfields and glaciation evidence. Is it okay, all of you here? Okay. So that completes the 4 evidences of Wegener. Okay. Give a subheading. Driving mechanism. The next is driving mechanism of what moves the continents. Of what moves the continents. So, ये idea, now see, again understand, Wegener is not a geomorphologist. Wegener is not a geologist. He doesn't know much about geophysics. क्यों हो रहा है? So when he made such a big statement, the continents are moving, and look at the evidences, look at the processes, he must have been asked about कि ठीक है अगर आप बोलते हो continents move कर रहा है, तो आप ही बताओ क्यों कर रहा है? They must have questioned him a lot to explain why continents are moving. He didn't think too much. He said, okay, I will go by what Taylor said. So what did Taylor say? Move because of the gravitational pull of sun and the moon. इसमें उन्होंने ऐड कर दिया consequence of Earth's rotation. Earth is spinning, and when the Earth spins, the continents can also get thrown. Okay. Plus, he added some absurd idea of imbalance between the center of flotation and the center of gravity. ये कुछ एक अपना आइडिया डाल दिया इन्होंने. What basis? How did you work this? We have no idea. So no point explaining this. Your book mentioned this, मैं बस mention कर दिया. There's some anomaly in the center of gravity and center of flotation of the continents. Okay. इसमें what is this मत पूछना because ये absurd idea है. And when these ideas were given by Wegener, तो बाकी जो geomorphologists थे, बाकी जो geophysicists थे, they literally pounced on him. But these are very absurd possibilities. They did mathematical calculations. They found if the sun and moon can have so much of force that they can move continents, फिर तो अर्थ का रोटेशन है वही रुक जाएगा. Earth can't rotate if the sun and moon are capable of such strong gravity which can move the continents. They have done mathematical calculations here. Okay. So this idea, the driving mechanism का जो idea था, इतना गलत था that Wegener's theory entirely was discarded. Okay. Then they said, this man is a madman. वो जो भी कह रहे हैं सब गलत से बोल रहे हैं. And the drift theory ultimately was rejected completely. Okay. So there are two lines on this. Wegener used Taylor's interpretation of driving forces. Wegener used Taylor's interpretation of the driving forces. Number one, the gravitational pull or the tidal pull of sun and moon. The tidal pull of sun and moon. Number two, force because of Earth's rotation. The centrifugal force because of Earth's rotation. And number three, an absurd idea of the imbalance between the center of gravity and center of flotation or center of buoyancy बोलते हैं. Imbalance between center of gravity and center of buoyancy. B-O-U-Y-A-N-C-Y. Buoyancy of floating continents. Next point, next paragraph देखो. The driving mechanisms were dismissed by geophysicists. The driving mechanisms were dismissed by geophysicists. And the theory itself was discarded. Because see, this is part of the rivalry in the scientific communities. वहाँ भी अच्छा खासा चलता है politics. Okay, so I am right, you are wrong, my research is better, your research is not appropriate. It goes on there. So when Wegener is challenging the established, the then accepted ideas of geophysics, when Wegener is challenging the established scholars of those times like Harold Jeffrey, so those guys are upset. Okay, and their arrogance may that this man knows nothing. He's not even a geomorphologist, not even a geophysicist, and talking about land, which is our domain. He's a man of climate, let him remain there. So they kind of dismissed him completely as a madman. In fact, Wegener died a very miserable man. I mean, nothing is more hurtful for a scientist than his ideas not being heard. Okay, scientist का तो पूरा pride वही है ना, that I'm researching, I'm discovering things, let's just collaborate, let's discuss. Okay, but Wegener was declared as a complete absurd idea. Okay, so that's how the drift theory ultimately was discarded. And then new research comes in, new ideas come in, and almost 20-30 years baad mein, and in 50s onwards, they again see some amount of revival. Yes, continents can move. Take all of you. So, give a subheading. Yes, Priyanka, correct. So, the geologists and the geophysicists saw this as unnecessary interference by a person who did not have knowledge in geophysics. Okay, they said that you are a man of climate and climatic processes, stay there. Yes, it was more of an academic rivalry that got the better of Wegener. Right now, give a subheading, analysis of Wegener's theory. Analysis of Wegener's theory. 3, 4, 5 lines. Okay. Analysis number 1. A very bold and a revolutionary theory. A very bold theory and a revolutionary theory. Number 2, was able to give very convincing evidences of continental drift, which are still valid. Number 3, the first man to comprehensively challenge permanency of oceans and continents. Challenge permanency of oceans and continents. Next, the idea of oceans getting scraped. The idea of oceans getting scraped and the sediments forming mountains is still valid. But not like how Wegener explained it. कि जो fold mountains होते हैं ये ocean है. The ocean has marine sediments. The ocean has marine features. ये बात सही है. That these sediments they get scraped. Okay, ये सब इकट्ठा होके continents के edge में they form mountains. ये सही बात है. But it is not like how Wegener said. Wegener said the continents are floating on the ocean. वो गलत idea है. Reality में continents के अंदर में we have ocean floor subducting is going inside. This is creating scraping of the sediments. Then bracket that down. The correct theory is the ocean floor scraping because of subduction process. SUBDUCTION. Because of subduction process. And not Sial floating over Seema. So I'll explain this what it is. This is part of plate tectonics theory. So idea कि mountains जो हैं, they are the sediments of the ocean floor. ये सही है. And the sediments are getting scraped. कोई उनको काट के निकाल रहा है. and the sediments pile up, but not like how Wegener was explaining the mountain building process. Next slide down. His idea of Sial floating over Sima is also inaccurate. The idea of Sial floating over Sima is also inaccurate. In reality, it is the continents and the oceans together, as part of lithosphere floating over asthenosphere. The oceans and the continents together as a part of lithosphere floating over the asthenosphere. So, what is Wegener saying? Wegener says there is a Sima block, and over Sima we have the continents. The Sial floating over Sima. हम बोलते हैं ये मॉडल गलत है. Actually क्या है? Actually it is, there is continent Sial plus there is the ocean Sima. Both are side by side. Both of them, okay, as a part of a larger lithosphere. This whole thing is floating over, okay, the layer called as asthenosphere. ये मॉडल सही है. It's not Sial over oceans. It is Sial and oceans together as part of lithosphere. This is your lithosphere. This is the lithosphere. And this is the asthenosphere. The model of oceans continents is wrong in case of Wegener side. Okay, so it's not Sial over Sima, it's Sial and Sima, side by side, as part of lithosphere floating over the asthenosphere. All good, all of you? So this is an example of how to write something that demands critical evaluation. Okay, so don't just give me the theory. आपको बताते रहना पड़ेगा कि what is right and what is wrong. How is it good and how it has limitations. Then becomes an answer of critical evaluation of Wegener's theory. Okay, the next point. Yes. आप बताओ ये क्या है? एटमॉस्फेयर तो ये है. ये वाला पार्ट क्या है? आप बताओ. हाँ, सियासीमा तो नहीं है, मुझे पता है. ये क्या पार्ट है? अपर पार्ट ऑफ अपर मेंटल. कुछ सालों पहले पढ़ाया था मैंने. राइट? दिस थिकनेस वाज हाउ मच? 100 किलोमीटर्स. आप 10 कदम जा रहे हो, पीछे का भूल रहे हो. कीपिंग योर माइंड ऑलवेज फ्रेश. राइट? Okay. So he had the courage to ask, but बहुत बैठे हैं वो क्लास में. Okay, सर ये क्या है? ये कहां से आ गया? The upper part of upper mantle, and this is the lower part of the upper mantle, up to a depth of 350, 400, whatever kilometers. Okay, let's move on. The next point is the biggest limitation of Wegener was his driving mechanism. The biggest limitation of Wegener was his driving mechanism. That was completely erroneous and dismissed. that was completely erroneous, and therefore it was dismissed. What's the idea? The tidal pull of sun and moon, the centrifugal force, okay, and the concept of imbalance between center of buoyancy and center of, okay, the center of gravity. So he had used one term, or maybe go back to the previous page where I discussed the driving mechanism. ये जो centrifugal force है ना, okay, this he called as pole fleeing force. Okay, well, I forgot to mention that phrase. That force because of Earth spinning that creates centrifugal force. It's called as pole fleeing force. Pole fleeing force. Okay, the pole fleeing force is responsible for the northward motion of the continents. This was Wegener's idea. The pole fleeing force. Just to explain this to you, imagine I hang a small stone from a thread. Okay, it's hanging from a thread, and I start rotating the string. I'm spinning the string here. क्या होगा बताओ? Won't the stone get thrown upwards? And if I spin really fast, it's possible stone can come here also. Can you all imagine here? Because the spinning of the thread will throw the stone outside. Okay? So what Wegener is saying is, Earth here, Earth is spinning. Because Earth is spinning, the continents which are here, they will get thrown towards the north. The continents are moving away from the South Pole. They are thrown away from the poles. Away from pole is away from the South Pole. That's how the continents are moving northwards. Have the continents moved northward, yes or no? Yes, they have. But not like this. And कोई जरूरी नहीं है, the continents will move only northwards. We have examples of continents even moving southward also. Example of Australia moving eastward also. Okay, but he had said all continents will move only northwards because of the pole fleeing force linked to Earth's rotation or Earth's spinning. Okay, so back to analysis. Okay, analysis. The same point what I'm discussing. The tidal pull of sun and moon. The tidal pull of sun and moon, if as strong, the tidal pull of sun and moon, if as strong, would have stopped Earth's rotation. Would have stopped Earth's rotation. And the pole fleeing force because of Earth's rotation can't explain all the possibilities and the directions in which continents can move. All the possibilities and the directions in which continents can move. ठीक है, तो कोई जरूरी नहीं है continents will move only north and westwards. Put a star mark. Wegener's idea that continents can move only north and westwards. Continents can move only north and westwards was an incorrect idea. Was an incorrect idea. Is it okay, all of you? All fine? So my question now, so did the continents actually move or not? Yes. So is the idea called continents drifting right or wrong? Right. What is wrong is the drift theory. What's wrong is the way he thought continents are moving. Okay. So the idea of continental movement is right. The idea that oceans, continents are not permanent is right. But not the details of his postulates. Sial over Sima, the tidal force, the scraping because of flotation, both are ideas galat hai. Right? Therefore, while the idea called continental drift, is correct and laid the foundations of, the future tectonics theory. The idea of continents drifting, moving is correct, and it laid the foundations of the future tectonics theory. Wegener's mechanism of how the drifts happen, okay, was incorrect. हम बोलते हैं कि ड्रिफ्ट थ्योरी गलत है, the idea of drift is right. Because the idea of drift is right, therefore his evidences of drift are all right. Now we got the point here? Yes, coastline match sahi hai, that the continents were once together. Rock match sahi hai. Okay, there is some similarity of the rocks on either side of the oceans. The fossil evidence is a very good evidence because they are evidences of continents moving, not evidences of the detailed theory. वैसे theory में सब कुछ आ जाएगा, सियाल भी आएगा, सीमा भी आएगा, flotation भी आएगा, Pangea भी आएगा, वो सब आ जाएगा. ठीक है? Tanishq. Okay. Now see, Earth here, continents are here, and there is moon, there is sun. Essential idea is the moon is pulling, the sun is pulling. When it pulls, and Earth is rotating like this. तो क्या होगा कि continents पीछे रह जाएगा and Earth has moved ahead. It looks like the continents are moving westwards. Okay, but in this process what happens is कि अगर इतना powerful है, the continents can be held back, फिर Earth का घूमना ही रुक जाएगा. The whole Earth also gets pulled, right? Tanishq. ठीक है? So westward motion of Wegener, he said it is because of the sun and moon pulling, and the northward motion is a consequence of pole fleeing force or the centrifugal forces. Okay. And we say all of this is wrong. हाँ, वो limitation नहीं बोलेंगे. Okay, we'll just call it as an incomplete theory. वो भी ऐड कर सकते हो. The Wegener did not tell us about the formation of Pangea. I think लिखा ही दिया था आपको मैंने कल notes में. What happened before the Carboniferous times when Pangea existed? ठीक है, all of these are some of the gaps. अभी शुरू किया हमने, अभी नेक्स्ट 15 दिन यही पढ़ने वाले हैं. ठीक है? Southward motions. Fatima, in this theory, there is no southward motions. In this theory, it's only northward motions. Okay. For southward motions, we need other concepts. First, we discard Wegener, then we enter the other theories. Anybody else here? Okay. Chalo, so this is the part of the drift theory. Now take a fresh page. Developments towards the modern plate tectonics theory. The developments towards the modern plate tectonics theory. So, 1912 is when Wegener gave his theory. By 1920s, it was translated and it was known in English and also discarded. And uske baad kya hua? There was a gap. Okay, Wegener was not considered, and 1950s mein again the idea had some revival. Okay, and this revival is what became the plate tectonics theory. So either jump hua from here to here, some developments were happening here, some discoveries were made here, and those discoveries were put together in 50s and 60s as the plate tectonics theory. Okay, so syllabus में आपका drift theory है और ये वाला है. ये नहीं है, but लेकिन questions आते हैं इससे. Let's just have some small conversation on what were the development towards the modern plate tectonics theory. All good here? So there were two important developments. Number one is the concept of convection currents of the mantle, given by Arthur Holmes, 1928. And second was the concept of sea floor spreading and sea floor spreading of Harry Hess and extensive mapping of ocean floor. These two things creates the basis of tectonics theory. The convection currents hypothesis given by Arthur Holmes in 1928, and the second is the sea floor spreading hypothesis, a theory of Harry Hess. Harry Hess, along with extensive mapping of the ocean floor. There was one lady called as Mary Tharp. She had a lot of works on ocean floor mapping. M-A-R-I-E, Mary Tharp, T-H-A-R-P. Okay. In fact, Harry has used lot of studies of Mary Tharp. Okay. So quickly, first, what is the convection current hypothesis? Convection currents hypothesis. ये मैंने बता दिया आपको. I'm just repeating it quickly. Recap. The mantle is solid, but the mantle is capable of motions. Okay, mantle can melt in parts, and the magma starts circulating. Basically, any convection cell होता क्यों है? Why? Is a mechanism of energy transfer. If I have a heater here in the room and the heater heats the air, okay, the air expands, it rises, and that's the mechanism of how the heat energy gets distributed. That's how a convector works. The mantle convection cell are a consequence of that type of energy differences. Inside the earth, okay, the parts which are very, very hot compared to the parts above. The parts which are very, very hot for some reasons compared to the layers above. Because of this, this will hot, it melts, expands, it will start rising, it keeps on melting the rocks above, and it starts circulating. So these are essentially mechanisms of energy transfer. इसी से volcanism होगा और यहीं से energy release होगा धीरे धीरे. The mantle, because of difference of heat, okay, the interiors are more and more hotter, okay, because of difference of temperatures, difference in internal dynamism of radioactivity ho ya kuch bhi ho. The hottest temperatures are where? Core is 5000, outer core 3000, 4000 centigrade. So the deeper parts are hotter, and there's a mechanism how the energy can be released. One mechanism is, I've told you, it is your mantle plumes rising directly. Other is convection cells. So mantle is not a static entity. Something is moving inside that. Okay, write down. The first is convection currents hypothesis of Arthur Holmes. Okay, write down that Arthur Holmes proposed the idea. Arthur Holmes proposed the idea that because of differences in the heat energy in the interiors of Earth, because of differences in the heat energy in the interiors of Earth, the mantle in parts can melt. The mantle in parts can melt and circulate through vertical convection cells. Circulate through vertical convection cells. Remember this thing, that this is hot, air is rising, और जो lithosphere है ऊपर, the lithosphere is a very hard layer. Okay, lot of power, ये टूट सकता है, but it's still hard. Okay, so some lava comes out, yes it does, but bulk of it can't break through. It moves under the lithosphere. Okay, and that's how it circulates. अगर पूरा टूट जाता तो फिर the whole thing is out now. That energy release happens slowly, gradually, and we have volcanisms, we have volcanic eruptions and so on. So convection cells essentially are mechanisms of energy release from the interiors of the Earth. Write down. The convection cells can operate at any depth. The convection cells can operate at any depth, depending on the heat inside. The convection cells are powerful enough. To drag and pull. They are powerful enough to drag and to pull the lithospheric plates on the Earth's surface. The lithospheric plate on the Earth's surface. Take all of you. Okay. Now, one thing, while tectonics, the modern theory है tectonics का, it says yes, all the dynamism that I find on the surface, ये continent move कर रहा है, collide कर रहा है, जो भी हो, volcanism है, these are not because of sun and moon outside. They are because of what's happening inside. But tectonics can't explain the exact mechanism why the cells are formed. यहीं पर ये सेल क्यों है और यहां पर क्यों नहीं है. And it can't explain when the cells can die also. There are some gaps in tectonics theory. Add karo. While the modern tectonics theory is based on the convection cells as the primary driving force. Based on the convection cells as the primary driving force, the theory can't explain the exact mechanism. The theory can't explain the exact mechanism in the genesis of the cells. In the genesis of the cells, and why some convection cells intensify and why some cells weaken and die off. Why some cells weaken and die off. ठीक है, तो ये एक मिस्ट्री अभी भी है. ये सेल यहीं क्यों बना, यहां क्यों नहीं बना. ये सेल, okay, why is it, okay, sometime becoming strong, and the cells can be any direction. They can be like this, your left, your right. It can also be, okay, towards you and away from you, in any vertical plane. अगर left right ऐसे चल रहा है, the continents will move like this. If आगे पीछे ऐसे चल रहा है, the continents will move towards you or away from you. So the direction of plate movements is not always north and westwards. I hope you got the point here. Let's add one point here. Yeah. Yeah, but यहीं क्यों, यहां क्यों नहीं? So it's not as simple as that. Radioactive material across the interiors है. ठीक है? So there are some gaps there. You can't explain solely on the basis of radioactivity as an idea सही है. But यहां क्यों trigger हो रहा है, वहां क्यों नहीं हो रहा? That's the question we do not know. ठीक, all done? तो एक point add कर लो, write down that the dynamism of the Earth's surface, the dynamism of the Earth's surface and the plates movement, the dynamism of the Earth's surface and the plates movement are therefore linked to the convection cells of the interiors. They are linked to the convection cells of the interiors, and not because of the tidal pull of sun and moon or Earth's rotation. The tidal pull of sun and moon and Earth's rotation. ठीक है, जो मिस्टेक वेगनर का था, talking about the movement as a consequence of the sun and moon's tidal force, so that has now been taken care of. So all the dynamism are linked to the internal forces, the mantle dynamism, na ki some absurd idea of whatever Wegener was telling us along with Taylor's ideas. Take all of you. So this can be a short note on convection cells. I think I have shown the diagram to all of you. आपके नोट्स में भी ऐड करवा देंगे हम. Where is it? Missing in the listen. The one I showed yesterday. Here. Sorry. There it is. याद है ये वाला diagram? Okay. So convection cells rising and they're moving apart. When they move apart, something else pulls here, something else pulled here. So it is this cell that moves the plates which are on top of the convection cells. Yeah, Rohit. Thanks. Yes, correct. Anybody else here? Any doubts? Okay. And let's move on towards the next concept. This also I think I've shown yesterday. Yes. Okay. So now we have the sea floor spreading hypothesis. This was given by Harry Hess along with his academic partner Dives. Okay, but this is the main man who is given the credit. Sea floor spreading hypothesis. सुन लो पहले, then I'll give the notes to all of you. Abhay, see, these are not works of, 1 or 2 days. ये पूरा life लगाकर, okay, he would have known what is the concept of convection cells. And then it takes time for the ideas to get accepted. Then again you build on that. It's not as easy linking concepts across. Okay, so it takes time for it to become a part of a theory. Yeah, you can also call this a theory also, no problem. Hypothesis is when it's an idea not well explained, but you have theory established. Now watch. See, what they're saying is, this is the Earth, and say that's the continent, this is the ocean, continent, and this is a large ocean, and we have another continent here, the interiors of Earth, and there is, say, a convection cell. There is a convection cell. The cell will have rising limbs, diverging limbs, okay, and somewhere it will have sinking limb and come back and converge, sinking limb and come back and converge. So this is already in operation. What Harry says is that this process can break the ocean floor. ऐसे टूट जाएगा. And this rising lava will force some amount of volcanic matter here, and these diverging limbs will pull the ocean floor away. ये बाहर खींचेगा. Okay, and as the gap increases, more lava will come out and will keep on sealing this. Again move out, again lava comes up and seals it. So it's like this. Initially, imagine this is the ocean floor. Block A, lava rising, puncturing this, pushing apart, lava coming out, But block A will move here. Block A will move here. A new lava B is forming here. And some amount of accumulation here also. It goes on. A comes here. A comes here. B comes here. Now a new C is formed. A is here. And above C, you again will have some amount of accumulation. Okay. This part is the convection cell. Pulling like this, pulling like this. Okay. The process goes on. This is A, this is B, A, this is B. The process goes on. Ultimately, you'll find the ocean floor is here. The ocean floor is here. And there is some lava accumulations here. Such that this is the oldest ocean. Pehle bana tha. This is a bit more young. This is a bit young. This is the youngest ocean. This is the youngest ocean. And you move away, this will be the oldest ocean. It starts with, he says, a small ocean here. This small ocean, ye phail gaya. Continent was here. Continent was here. Okay. This ocean is rising. Okay. And the continents are getting pushed away. The continents are getting pushed away. You all imagine here? And ocean जो ये था, अब ये ocean बन गया आपका. This is a process of the ocean seems to have spread, elongated and become large. Okay. So this is essentially linking the convection cell theory of Arthur Holmes with what they found on the ocean floor. They got 1940s and 50s was the time of the world wars. Like 40s World War, 30s World War chal raha hai. World War means ocean routes, navy attacks, submarines. In the world wars, lot of ocean floor mapping was being done. And they found ocean में ऐसे बहुत सारे features. They found ocean floor is basalt, where continents are andesite. They found on the ocean floor these type of mountains where there is lava coming out. This is called as the Moor system, mid-ocean ridge system. They found the oceans far away are older oceans. At the Moor, they are younger oceans. They found this lava coming out. So I have drawn the cross section here. ये बनाया मैंने. The fact is, ये पूरा ऐसे होगा ना, पूरा extended like this. Can you all imagine? ये पूरा ऐसे extend होगा ना, like this. So this is like a mountain range. This is the Moor. All of this was mapped during the 30s and 40s and 50s. And this is a massive crack. Okay. A crack along which the ocean is expanding. A crack along which the ocean is expanding. Okay. This is like a rift valley. Like a rift valley. So when the ocean mapping was being done, all of these discovered. And what Harry Hess does is links all the observations with the convection current hypothesis. And so this is how oceans are formed. And the lava coming out here is what becomes the basis of the ocean crust creation. A question tha, remember? How did the ocean and the continent separate out? Why does ocean become basalt and why does ocean continent become andesite? Okay. So this is one of the reasons. I'll explain ultimately again. But the ocean formation is linked to this process of convection cells and the basaltic lavas at the Moor locations. ठीक है? So I'll just show some diagrams before we write some notes here. Can you all see this diagram now? This is the convection cell. Convection cells here. Lava is rising. Lava rising breaks up here. It becomes a crack. These triangular ones are the mountains. Okay. And this rock is a basalt rock. Okay. And rising limb will create lava. Okay. And where the limb is sinking, okay, the ocean floor also gets pulled inside. This is called as the process of subductions. The oceans are formed here and oceans are destroyed here. Okay. So this process is one of the fundamental process of how the plate tectonics operates. You have one more diagram of this kind. This one. Okay. So again, convection cells, rising lava moves here. Rising lava creates these mountains. We have called these as moors. ऐसे elongated होगा मोर पूरा. This is the Moor system, and this lava is what becomes the lava of the ocean. This is the basalt volcanic rocks that make up the ocean floor. ठीक है? Back to your notes now. Yeah. और भी बहुत कुछ है. ये हैरी हेस बोल रहे हैं. ठीक है? For Harry Hess, it's impacting only the oceans. Okay, we'll stop here for now. बाकी आगे बताएंगे आपको. Okay, write down now. According to Harry Hess, number one, according to Harry Hess, number one, the convection cells of the mantle, the convection cells of the mantle impacts the ocean crust above it. Impacts the ocean crust above it. Number two, at the location of the rising limb, volcanic eruptions happen. Creating volcanic elongated ridges. Within bracket लिखो आप basalt accumulations. Bracket closed. Called moors, M-O-R, mid-ocean ridge. Called moors or mid-ocean ridges. Okay? I repeat, at the rising limb, there's volcanic eruptions here, and the volcanic eruptions will form some ridge system, mountains here. Ridge is what? A mountain elongated one. Okay. And this lava, for some reason, is basaltic lava. It forms lava accumulations here, which are basalt accumulations. We call this as mid-ocean ridges. Put one reminder here. Moors are not like fold mountains. Moors are what? Moors are volcanic accumulations. Fold mountains are what? They are sedimentary marine deposit accumulations. ये दो अलग चीज है. Moors are not fold mountains. Moors are marine deposits accumulations. Sorry, yeah, marine accumulation. Fold mountains are, I repeat, moors are volcanic accumulations. Fold mountains are marine deposit accumulations. Fold mountains are marine deposit accumulations. They are marine sedimentary rocks in case of the fold mountains. Okay? Next. Next. With the convection cells, diverging limbs. With the convection cell diverging limbs, the ocean floors are pulled apart. The convection cells diverging limbs, the ocean floors are pulled apart. They are pulled apart. So ocean floors are spreading. So ocean floors are spreading. Abhirup, moors are mid-ocean ridge. Moors are mid-ocean ridge. And these are volcanic basalt accumulations. ठीक है? So with the diverging limb, ये lava ऊपर गया, some lava comes out, the limb now diverges out. Diverges out, the ocean also gets pulled like this. That's how we are saying oceans are getting spread. ये फैल रहे हैं. Next. Next. At the moors, there are axial rift valleys. At the moor, there are axial rift valleys that mark the splitting of the ocean floor. There are axial rift valleys that mark the split of the ocean floors. Okay? So, it's like a crack. This is like a crack. The ocean floor. The ocean floor. That's the moor. And this is the crack. This crack here. This crack is a rift valley. A rift valley that marks the spreading zones of the oceans. So every ocean floor spreading will have such a crack in between. It'll have a crack in between. Take all of you. It's called as an axial rift valley. Why axial? Because it's along the axis of the moor. ये पूरा आपका moor है. It's along the axis of the moor. It's called as the axial rift valley. Next. Because of such spreading, the ocean floor is younger, with younger basalt rocks near the moor. Because of such spreading, the ocean floors are younger near the moor. And the ocean floor is progressively older away from the moor. The ocean floor is progressively older away from the moor. जब आप age mapping करोगे, this is the oldest one. And you come towards the moor, this is the younger one. And धीरे धीरे ये इधर आ जाएगा. Okay, that's how it spreads like a conveyor belt. Example बताया ना आपको मैंने? The first, I will have AA rocks. The AA rocks are displaced by BB rocks. Then the AA comes here, the B comes here, the C rocks are forming here. This is A, this is A, this is A, B has formed in between. Then A is here, B is here, a C has formed in between. Can you all imagine here? Okay. So what is formed here ultimately will get pushed and new lava will form here. That's how this is the oldest one. Youngest rock यहाँ पर होगा. The ocean age becomes progressively more as I move away from the central mound. Next. At the locations of sinking limbs. At the location of sinking limbs, the ocean floor can be pulled into the mantle. The ocean floor can be pulled into the mantle. With a hyphen, the process called as subduction. The process called as subduction. So, this is rising limb. Okay, it's spreading out. जहां पर नीचे जा रहा होगा, the ocean floor gets pulled in. It's called as subduction. So, imagine convection cell. Rising, lava rocks forming, ocean getting pushed, subduction, goes inside, melts, and again comes back, and again eruption here. It's almost like the ocean floor is getting recycled. बाहर आ रहा है, बन रहा है, दूर जाके subduct, again back, again melting, again rising. The process of ocean floor recycling going on. Head down. The subduction process results in destruction of the ocean crust. It results in the destruction of the ocean crust. Put hyphen, a very important basis of plate tectonics theory. A very important basis of plate tectonics theory. Achha, now watch here. Imagine this is the continent here, and this is the ocean, and the ocean going down like this. This is what rocks? Basalt. This is what rocks? ये continent है तो क्या rocks होगा? Andesite. And जहां पर subduction हो रहा है, वहां पर एक gap बन जाएगा ये वाला, called as the trenches. So these features were found on the floor. हैरी है समझा रहे हैं कि trench कैसे बन रहा है. Write down. Next point. The location of subduction of ocean floor will have deep valleys like depression. Called trenches. The trench actually valley नहीं है, वो क्या है? वो gap है. The gap between the ocean and the continents, or the gap between the subducting slab and the other slab. ठीक है? And when going down, ये जो ocean sediments हैं, landforms हैं, जो भी हैं, they will get scraped here and they will accumulate on this side. Can you all imagine here? It's like, I apply shaving foam and I have a blade running on my skin. Okay, the shaving foam will get plastered on my blade. So, ये continent है, this is the ocean floor going down. It's going down, the continent acts like a razor. It is scraping the sediments and accumulating on this edge here. Okay. So, the idea of scraping was right of Wegener. Wegener क्या बोल रहे थे? The oceans are getting scraped. He's right. but not because continents are floating on oceans. The scraping because the oceans are subducting. While subducting, the sediments get plastered along the edge of the continents. Write down. The subduction process will create compressive and scraping forces. The subduction process will create compression. यहाँ पर compression हो रहा है. And scraping processes where sediments of the ocean floor, the features of the ocean floor, मतलब ओशन के ऊपर में कोई माउंटेन यहां पर है, ओशन के ऊपर में कोई प्लेटो यहां पर है, there are some islands here maybe. So the sediments and the features of the ocean floor, okay, will get scraped, broken, will get broken, crushed and deformed. Will get scraped, broken, crushed and deformed, and plastered against the other slab. And get plastered against the other slab. The ocean slab है जो जा रहा है, they'll get plastered against the other slab. So they'll pile up on this side here. Okay, this piled up matter is called as accretionary prism. Okay. Write down, the scraped sediments are called as accretionary prism. ACCRETIONARY. They're called as accretionary prism. They called as accretionary prism. ठीक है. So देखो मैं क्या क्या समझा रहा हूं आपको. While explaining the sea floor splitting process, I've explained what is a moor. बताया आपको मैंने. Why the moor has, okay, the rift valley. Why do we have age of the ocean increasing from the moor? I've explained why the oceans are a volcanic basalt. ये basalt mantle से आ रहा है. I've explained why do we have trenches. I've explained why and how is the accretionary prism formed. So when they're surveying the ocean floor, ये feature मिला था इनको features. They found all of this. They did not know how to explain it. The Harry Hess का brilliance यही है. He links what was found on the ocean floor with the convection current hypothesis. जोड़ दिया इन्होंने. ठीक है? Now one more point here. देखो. The ocean is not a small slab. Massive, imagine north-south है. Okay. So this is your ocean. Very extensive. Very extensive here. Okay. This is your ocean slab. Okay, so it's a very large part of the ocean floor. And everywhere you have convection cells. इधर भी, यहां भी खींच रहा है, यहां भी खींच रहा है, इधर भी खींच रहा है. I hope you can imagine the convection cell now. The convection cell is not, we are making the diagram as this. ऐसे line बना दिया. You can all imagine the convection cell actually is a two-dimensional thing or three-dimensional thing. So if I imagine, say, this is the convection cell, okay? Rising limbs like this. The rising limbs of the cells like this. You are seeing from the front. But can you see it's a very large part here? It's a three-dimensional sheet is coming out like this. And this is thousands of kilometers. Starting from here, yahan tak, thousands of kilometers. So will the force everywhere be same? It's possible na ki in this part, this pull is more than this one. In this part, this pull is more than this one. It's possible. You go further away, शायद ये pull ज़्यादा strong है इससे. So by and large, they're almost symmetrical. But in some places, one part may be a bit more stronger than the other one. Somewhere else, this may be a bit more stronger than the other one. It's possible there. So what happens is that this more that I'm drawing, rather than being a straight line like this, ये आपका more है. It's like a straight line I've drawn. ये more straight रहेगा नहीं. Okay. This part can get pulled a bit more on this side. This part will get pulled on this side and there'll be crack here. The mores typically look like this then. This is one part of the more. This is another part of the more. This is another part here where there's a crack here. There's a crack here. I hope you all can imagine what I'm trying to show you. Can you all visualize this now? And this is the ocean floor. This okay now? Rather than the more being a straight line, the more has got sliced. One part has gone this side, ज़्यादा नहीं, थोड़ा चला गया है. And these are cracks. एक तो crack आपका along the more है, and you also have cracks across the more like this. ये जो convection cells हैं, the convection cell rising here and rising on this side, by and large symmetrical होते हैं. But it's possible in some parts, this is a bit more stronger than this one. Imagine you have a pipe. आपने पाइप ऊपर कर दिया, पानी निकल के छत पे जा रहा है. अगर एकदम perfectly vertical पकड़ोगे, water will hit the roof and water falls like a fountain like this. Is it possible? ये पाइप आपका थोड़ा टेढ़ा है. Okay, where this water is more than this water. That's it. Because this is not a small area. This is 7,000 kilometers long. इतने बड़े एरिया में how can the force exactly be same in both the sides? In some parts ये ज़्यादा खिंच गया. In some parts ये ज़्यादा खिंच गया. That's about it. Yes. Yes. When you have a cut and it's bleeding continuously, okay, will the cut get closed completely? Even if blood is coming out, the cut is there, right? Something of that kind. Lava is rising and the gap is there. Yeah, even in this one, there is movement going on. It's not that the whole thing gets split and broken apart like this. So whatever lava comes out, okay, the friction is enough to create the small cracks. These cracks are not deep cracks, they are shear cracks. So a typical look of this, you may have missed it here, dekho. Ye diagram dekho. Can you see here? Okay, the more is here with some crack here, and then we have again more here, again a crack here, again a more here. These are not deep cracks. They are much shallow compared to this crack here. This is a very deep crack across the entire thickness. In fact, along these cracks, यहाँ पर lava भी निकल नहीं रहा होगा. The lava coming out is here. Sorry, where is that? The lava coming out is largely along this, because this is right for the entire thickness of the slab. These are shallow cracks. They're not always through the entire ocean floor. So, यहाँ पर you won't even have volcanic eruptions here, but there are cracks. Is it okay? It's like summer season, khatam hua, winters aa raha hai. Your body will develop cracks, right? Some cracks can be so deep it will start bleeding also. Winter mein your lips start bleeding, right? But it's not that ki pura body bleeding ho raha hai. I can have roughness, cracks here, put ointment, whatever. So some cracks are deep, you can have bleeding. Some cracks are superficial cracks. Think of something of that kind. So these cracks, they call these as transverse faults. They are also called as transform faults. They cut across the mores. And this one is called as the axial rift valley. Add a point in your notes back again. Just one sentence, okay? Because of differential rates of spreading on either side of the mores, because of differential rates of spreading on either side of the mores, the mores are not one continuous lines. The mores are not one continuous line. The mores are split into segments. The mores are split into segments by transverse faults. They are split into segments by transverse faults or transform faults, or by transform faults. आपको क्वेश्चन क्या पूछा था पता है? The question they asked was, what are the evidences of sea floor spreading? लिखना आपको यही था. The evidences are, देखो, put a box now. I'm summarizing all together. Aditya, is it okay now? Because of differential rates of spreading. Means the rate of spreading on this side is not same on this side. This has a bit more here. यहाँ पर spreading थोड़ा ज़्यादा इधर हो रहा है. यहाँ पर थोड़ा ज़्यादा इधर हो रहा है. यहाँ पर थोड़ा ज़्यादा इधर हो रहा है. Okay. The spreading rates are different. The rate of pull is a bit more here. In this case, the pull is more here. In this case, the pull is a bit more here. In this case, the pull is a bit more here. Okay. There's a difference because of differential rates of spreading on either side of mores. The mores are not one continuous line. The mores are split into segments by the transverse faults or by the transform faults. All done? Take a small list of evidences of sea floor spreading. बस मैं लिस्टिंग कर रहा हूं आपके लिए. Evidences of sea floor spreading. Number 1, presence of more. Number 2, the axial rift valley at the more. Number 3, increasing age of ocean floor away from more. Increasing age of ocean floor away from the more. Number 4, volcanic eruptions at the more. Basaltic eruptions hai. Volcanic eruptions at the more. Next, the subduction zones with trenches and accretionary prism. The subduction zones with trenches and accretionary prism. Next, the transform faults. The transform faults. तो बॉक्स में डाल दो. The evidences of sea floor spreading. The syllabus does not mention this, but without this there is no tectonics theory. Okay, it's assumed कि अगर tectonics पढ़ रहे हो, the base concept of tectonics is sea floor spreading. Without this, there is no continental motions. The prism is ocean deposits, ocean features. They are the crushed rocks, the crushed sediments of the ocean floor. Priyanka. Take all of you. Chalo, I think that's for today. I'm trying to make up the lecture I missed out. So thoda class badhakar, but let's see. So guys, you have your day off tomorrow. You also have your day off on Monday for Diwali and a third day on Tuesday also. Okay. So you have got 3 days off. We'll meet you on Wednesday. ठीक है. जिसको घर जाना है आप जा सकते हो. But my suggestion, Diwali, often guys, Diwali ORN की अच्छी होती है. ठीक है. And so nice, some people can't leave ORN at all. वो हर साल ही देखना चाहते हैं दिवाली. ठीक है. पर ठीक है, इस साल आप लोग देख लो. That'll be wise. Okay. अच्छा होगा कि आप पढ़ाई भी करते रहो, make up your backlogs, whatever you have, and catch you on Wednesday. I'll continue them. ठीक है. चलो, happy Diwali all of you, and take care of yourself. No injuries, please. Yes. Yes. Fold mountains. जितने भी fold mountains है वर्ल्ड में, all present. Atlas mountain.